Okay, the problem we have is A and B are two particles having same mass, right? So we have two particles A and particle B having same mass. A is moving along x-axis with the speed of 10 meter per second and B is at rest. Okay, so A is moving along x-axis, so let this be x-axis and this be y-axis. So A was initially moving along x-axis with 10 meter per second and B is at rest. After undergoing a perfectly elastic collision, okay, the collision given is perfectly elastic collision. Let's note this. With the B, the particle A gets scattered through angle 30 degree. That means 30 degree. Okay, fine. That means initially A was moving like this. It scatters through angle 30 degree. That is finally it's making 30 degree with its initial direction, right? So A went like this. What is the direction of the motion of B and the speeds of A and B after collision? Okay, fine. So we have to find in which direction B will scatter through. Let this angle be theta and the velocities of particle A and B. Let the speed of A be VA and the speed of VB VB. Okay, we have to find angle theta, VA and VB. It's a pretty simple problem given it's a perfectly elastic collision. Okay, how many unknowns we have? How many unknowns we have? So we have three unknowns. We have to find VA, we have to find VB and we have to find theta. Okay, to find three unknowns, we require three equations, right? One equation we can get is kinetic energy conservation. For perfectly elastic collision, kinetic energy is conserved, right? So we can get one equation from this thing. Second equation we can get from conserving momentum along x-axis, and third equation we can get by conserving momentum along y-axis, right? We must remember during collision linear momentum of the particles is conserved, right? Okay, by solving these three equations I can get these three unknowns. But here we can use a trick to make our problem simpler. The trick is when you have two bodies of equal mass and when they undergo oblique collision, and I hope you remember the condition for oblique collision, the line of velocity should be different, right? The line of velocity should be different. When they will collide obliquely, then after collision, the two bodies, let's say this was moving with velocity u and this was initially at rest. And this was initially at rest. Then after collision, the two bodies scattered at angle 90 degree with respect to each other. Though after collision, two bodies scattered at angle 90 degree with respect to each other. So this is a trick that I'm going to use in this question. So using this trick, I can simply say that theta is going to be 60 degree. So we have got one angle theta. So only thing that we are left with is how to find the velocity of A and B. Simply conserve the momentum along X and simply conserve the momentum along Y. Okay, let's do it. Let's talk about momentum along x-axis. So initial momentum along x-axis is equal to of the system. We are talking about the momentum of the system. So it is equal to mv. M into velocity was 10 and other momentum of the particle was 0. So total initial momentum is 10m. That is along x-axis. Final momentum along x-axis is equal to, you have to resolve both of them. So it's going to be, what is the momentum of this particle? The momentum is m into va. So have to resolve along x-axis. So what is the component of this along x-axis? That is equal to mva cos 30. Similar way, you have to conserve the momentum other body along x-axis. That will be mvb cos 60. Okay, let's note this down. So final momentum along x-axis is mva cos 30 plus mvb cos 60. So conserving momentum along x-axis, we are going to get 10 is equal to va cos 30 is equal to root 3 by 2 plus vb cos 60 is equal to half. From there you get va root 3 plus vb equal to 20. Equation number 1. Let's talk about momentum along y-axis. Initial momentum of the system along y-axis was 0 and final momentum along y-axis. Let's resolve these forces, these momentums along y-axis. It's pretty easy to do that. So y component of this momentum is going to be m va sine 30. And similarly, you can resolve this along as well. What we are going to get? mvb sine 60. Okay, so total momentum final along y-axis is going to be mva sine 30 minus, why minus? Because when two vectors are in opposite direction, vector sum is equivalent to scalar subtraction, mvb sine 60. So okay, conserving the momentum along y-axis, initial equal to final. So 0 is equal to va sine 30 is equal to half minus vb sine 60 is equal to root 3 by 2. From there, what you are getting? va minus root 3 vb equal to 0. Equation number 2. So we have two equations, two unknown. Let's solve them. After solving 1 and 2, va is going to be equal to 5 root 3 meter per second and vb will be equal to 5 meter per second.